Hello guys, welcome. I want to show you a project I built last week and I wanted to learn about load balancers and the best way to do it is just build one, right? So let's just see a little overview of it. So we have the client and the client send the request to one stable address. In this case is the 8080 address. And then the load balancer selects the eligible backend, forwards the request and returns the response and records what happened. For this project, I'm using mainly Docker because, yeah, with Docker we can run several instances and we can also um, make the backends healthy or disable the backends. So Docker is helping us to run the load balancer. Um, Also, we have a little front end dashboard. We're going to talk about that later and the three backends. So it's just very helpful to have everything running and just replicate this if we want to expand this to or like share to other developers. We also have the request lifecycle. We're going to go in detail about this later as well. The main strategy I'm using is the round robin strategy. So basically means that the load balancer, it will select the backends in a repeated rotation. So the request one will be to the backend A, the request two will be to the backend B, the request three will be to backend C, and you got the idea, right? We also have an alternative strategy, which is the least connections that selects the backend with the fewest active requests and uses a round robin order to break ties. And also we have health checks and we have failure isolation as well. So we're gonna go in details for this. Now, oh, what happened with my keyboard? Of course, when you are demoing something. Okay, so this one is the React dashboard I was telling you about. So we have some cards with the request, the backends available, the latency of the request. If we have some failures, we have a list of the backends that shows the name of the backend, the port, and also like the if they're healthy or not, some information, and a request list. So let's go into this. I'm already running the containers in Docker just to save time. But as you can see, we have the backends here, the load balancer, and the front end. Okay, so let's demonstrate the round robin strategy. So for now, I'm just gonna send a request. You see it, backend A, backend B, and backend C. All right. So we have three requests. Now, oh, I forget to mention, or did I mention that? Okay. So the dashboard is being updated in 5 seconds, and you can see we have the request and a little bit of information of it, right? So now I want to prove what happens when we disable a backend. We can do it either from the container or we can do it either from a request. I'm just gonna do it from the request, disable the backend C, and we have it here, right? If we check a snapshot of the backends, we will see that the backend C is not enabled. So if we go to the dashboard, it will show that it's disabled, right? And if we try to do the round robin again, it will show, okay, so we have the 200 with the A, backend A, we have the backend B, and now it comes back to the backend A because, yeah, the C is disabled. So if we enable the backend C again, we send the request, the request. And then we have healthy, enable, right? We have all of it, all the backends running. So if we go to the dashboard, we have the healthy one. We're gonna try it again. So now it will show like should show the backend, right? And how we know this? So, or like how the load balancer knows this. So we have health checks. We also have a log. Also have a cursor that checks the which is which one is the backend that is next after each request. we're gonna dive more into that. But first, also, I would like to talk about this project that has logs. So we have like, well, I'm showing the logs of the load balancer, right? So for the logs, we have the event, a method, a path, a status, a backend, and also we have a request ID. I'm using this request ID for have idempotency, meaning like one, like if we have some problem, like or we have like several requests, it will just produce one result. It will not create like two different results, so we're not gonna have a side effect. And yes, like these logs are always useful to track what happened with a request, or we have some kind of log service. And now we are going to dive into the code. All right, so now we're going to talk about the strategies. We have the run robin, like I was saying before. So we have to check first the backends that are available, and then we will choose a turn. For that, we have the cursor that checks which one was the previous one, and then when which one is going to be the next, right? So after that, we have the least connections policy, and this one just first chooses the eligible backend with the fewest active requests. This is useful when some requests stay longer than others, right? So basically, the run Roby focus on equal turns, and the least connections focus on which backend is the least busy right now. All right. So with that, this is the end of our demo. I just want to say that it was very useful to work in this project to understand the concepts behind a load balancer. That a load balancer combines routing, safety, health awareness, and also we have some retries, observability, and also it's been a while since I don't practice a little bit with Docker and just have like different containers running. So yeah, it was great to just implement all these tools in building this load balancer. And the purpose was not to replace like something in production or some or like these tools that we have, right, that handle this like in AWS or Envoy. Was just having fun and build something that it will help me to understand this better. All right, guys, thank you so much for your time and hope you like this video. Bye.